So, good morning, everyone. My name is Omkar. I'm a mechanical engineering student from BITS Pilani campus. And I worked under Sridhar sir, and my project is predictive habitat mapping for the Indian Oceanic region megafauna using spatial marine learning, machine learning. So, what the problem statement actually states that as the rise in blue economy as we have seen in the past decade or 2 decades, we see that many of the shipping routes has been going through the Indian Oceanic region, specifically the Arabian Sea side, and due to that, the whatever the developments have been happening in that region has been causing problems to the underwater megafauna, which are the whale sharks, humura sharks, etc. So now the shipping routes cut through the migratory corridors for blue whales, fin whales, as I mentioned. So what actually happens is previously whatever the marine protected areas were there, they were based on 2D spaces, not on 3D spaces. Now what we are trying to do is make it into a 3D model so that we can be getting more accurate protected areas and have better areas for and better policies for them. So can actually spatial marine learning help us in this model? So what we do is we use these data: sea surface temperature, chlorophyll A concentration, mixed layer depth, and the machine marine currents that are useful in the nutrient and other data, and seabed depth and slope morphology, etc., are all the other data that we use for the spatial learning models. So what actually physics works is that whales are not random walkers. They generally migrate only where there is a scarcity for food or they are looking for mating and all that other reasons. So what we are trying to do is look into all those all those parameters that are being used by them, and create a model that will run on that. So how actually upwelling works is whenever the wind blows over a particular oceanic region and the water is moving along with it, the deep, cold, nutrient-rich water rises to replace it, and because of that, whenever there is a rise in chlorophyll concentration, the more fishes are present there. There's a phytoplankton bloom, and there is a zooplankton expansion. So whales follow the zooplankton to the coastal regions. So that's how we see that Somali Current is world's most powerful upwelling system, and this creates an immense blue wave breeding season during the southwest monsoons, which are the current going season. Then Arabian Sea is one of them, and the Sri Lanka Dome, which is the uh, Kanyakumari part that we have been. So what actually happens is the observer bias issue is when we are able to track where the whales are. But the thing is, we are always looking at a particular shipping route or maybe where the research is already present. It's not, we all don't know where the whales are actually present or where they will be going, but it's just that we will be having bias sightings. So when there are bias sightings, the machine learning model is just works on what we data provide to it. So it will always corrupt the final results and we'll get wrong results. So for that, we will be working a new physics or mathematics. In this, we used a kernel density estimate in which we take the particular region where the humans have looked and not the whales, which actually where they are. And then we force the background sampling instead of random background points. We force the maximum entropy model to sample its background as the pseudo abscess is proportionally to the KDA surface and the matching. So we match the spatial distribution, and this will cancel the bias, and then we will be able to use the only biological models or the parameters that are being used, such as the chlorophyll model and etc. So now, what's the result of this? Maximum entropy model now evaluates where the only sea surface temperature is present, the chlorophyll concentration is present, and we get a better result and better score. So after running all these models and simulations, we get a map. So the thing is, this map is based on where I have used the kernel density estimate. Before it, it was surrounded with a lot of coastal points, but that would give us an inaccurate data because at coastal regions, the chlorophyll concentration is higher, but the whales are not being able to come because of the seabed depth, etc. So what we find is Somali coast and Arabian Sea self robust hotspots, and even after the bias correction, so we get to know that these are the hotspots for these particular species, and we validated this data with the telemetry data which the whales are being tracked. So not all of them species are tracked, but some of them are tracked, so we confirmed it with them. So the front-end architecture is when we get the data, we create an HTML file and we make a map of it, as I showed in the previous slide, and then we upload it to the on the website, and then we can also add which species are we looking, which season which we are looking for, and which particular area we are looking for. In that, we can be using this data for policy making in the future. Yeah, so real world policy impact. So the habitat map is not just a research output, it's an actually operational data layer which will help government or maybe marine bodies. So dynamic vessel routing is one of the solutions that we can do. So port authorities query the monthly heat map before approving transit plans. Then vessels are rerouted according to the protected area. So let's say there is a Mumbai coastal region. There is we see that migratory pattern is going to happen in this period. We will reroute the ships so that they will not go from there, but they will try and approach other ports. So routing adjustments, as I just mentioned. Then the seasonal speed restriction zones. Again, this is one of the major thing that we can do. As the URN is one of the major reasons for the ship strikes and etc. We will be maintaining a particular speed limit that will help the uh, megafauna to be, less affected by the URN and etc. And then we will be able to save the more megafauna using these. So yeah, what I actually plan to deliver is the bias corrected habitat model, which is the maximum entropy plus the boosted regression trees, which will be able to give us a scores, and using the scores we can plot where they are more so they can be present there. And yeah, the second is the live interactive web map, that in that which we can use species and etc. And yeah, that's it. That's my project. Thank you.